This is problem 113 of Neetcode 150, best time to buy and sell stock with Cooldown. So in this problem, we can actually buy and sell multiple times. There's another problem like that that uses two pointers technique, but this time we're going to use dynamic programming to solve this because it is more complex. So using only two pointers will be just not efficient enough to solve this. So let's go ahead and read the problem. So we're going to be given an array of integer prices, and at each position we have the price of a particular day. We can buy, we can sell this price, but we are also told that um, if we sell, we have to give a day of cooldown. So you can't buy the next day that you're selling something. So if we take a look at this example here, we can see there's a day where the price is at 0 and the next day the price is at 4. So just by our logic, we can tell that this is definitely something we don't want to miss out. We definitely want to buy at 0 and sell at 4. Can make $4 here. We can also buy at 1 and sell at 4 here. So we're going to make 2B. But the thing is that if we sell at 3, if we sell at 4 here, we are not allowed to buy at the 0 that is following because we need a day of cooldown. So the best option here will be to buy at 1, sell at 3, and then buy again at 0 and sell at 4. So we will make a total profit of $6. So let's go on our whiteboard and see how we can solve this problem. So we're going to use dynamic programming, and we are basically for each day is going to have a case where we sell or buy. That might be a little bit misrepresentative of what it actually means, because on each case, sell or buy, we are going to have the maximum profits we can have so far by selling or buying at that particular place. But not only by selling or buying, but also by holding back. Because if, for example, um, if we had like a, a one, another one, if this tree was replaced by another one, well, we will make absolutely no money. Or if it was a 0, that will be worse. Well, we will make basically no money here. So we will potentially appreciate to just hold all the time and then simply buy here at 0 and then sell at 4. So since we're doing dynamic programming and we're going to use basically bottom up, so we're going to start from the bottom and see what is the maximum profit we can make at every single position. Um, well, this is where we want to ensure that at every position, if basically holding the price at this at that day instead of buying or selling is gonna give us something that is um, better in terms of returns, well, this is what we are gonna be willing to pick. So you can see that here I have the prices for each days that we have in our example. So first day is 1, then it's 3, then it's 4, then it's 0, then it's 4. I have basically my column for S, which means sells. Then I have my column for B, which means buy. Notice that um, I also have an additional zeros here at the bottom. So if we take a frank look at this, and we see at the first day the case S sell, well, we are legitimate to ask ourselves, can we actually sell on the first day if we never bought? No, right? So we're not gonna take a look at this, and what we're gonna return is basically this first case. So at this first case, we can either buy or hold here. But one thing is that is sure is that we cannot sell at this first day. All right. So okay. With that being said, let's start here. So we're gonna start basically by doing some bottom up work. So if we buy here, so I also want to point out that I have the basically the prices in a graph here. So if I buy at the very last day, can I actually make money? Like let's say that this is basically the end of the market, right? If I buy at the very end of the market, can I make any money? Well, obviously no. So I'm gonna put a 0 here. But what if I sell here? In our problem, what we're gonna do, we're not gonna be that wise. We're just gonna ask, if I sell at this time, the price is 4. So we're just gonna assume that we're gonna make $4 on it, like that. So I'm gonna put a 4 here. Right, so now we did basically this entire row, and we can jump to this one. What if we buy at day zero? Well, the maximum profits we can technically make is that is the well, it's basically the next day's selling. So it's basically that 4 here minus the current price, right? So it's going to be 4 minus 0. So we can make $4 if we buy here. And for the selling, well, we can either sell at 0, which won't makes much money to us, or we can also hold it, because if we sold here, it means that we bought earlier. So in this case, what we're going to be willing to do is simply to add a 4 here, because we know that if we hold, we're going to be able to actually get that $4 instead of selling at 0 and losing everything. So now the 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 next thing we're going to do is that we're going to go see this next day. And what if we buy here at 4? Well, if you buy at 4, we're technically just going to check what is the maximum profit we can take with the next day by selling it, which is 4. So we know that at the end, we're not going to make any money on this path if we buy. So let's just try to hold the money here. And what if we hold the money? Well, we know that if we hold there, we can then buy on the next day at $0 and sell at 4. So the maximum profits we can make at this day, whether by buying or holding, is going to be 4. And the same principle is going to apply here. So on the day at 4, we can either sell, or we can just hold it, do nothing, and then wait for the next day to buy and take that greater profit here. So until we find something that gives us more money than, or basically our transaction of buying at 0 and selling at 4. Until that, we're just gonna put 4 everywhere. So we could technically just put 4s there, because we know that we're at least gonna make $4 even if we hold for the first couple days. We know that in the last 2 days we can make $4, which is the greatest thing we've seen so far. So now we can actually go see the day 3, see if we can make money. So what if we buy at day 3? Well, we know that we're gonna buy 3 and we can sell the next day at 4. So we're gonna make a profit of $1. But by holding again, if we hold and never buy, we're gonna be able to reach this day at 0 and buy this money, or buy this stock at price 0 and then sell it at price 4. So it's gonna give us a maximum amount of money of 4. And obviously 4 is greater than just buying here at 3 and selling at 4, which gives us only $1. So we're gonna let that be equal to 4. But now here comes the trick. If we go see here, right? So if we are at 3, well, what if we sell or price at 3? We're gonna make whatever happens before, we can make $3, and we can also make or $4 of profit here, right? Because notice that, let me just pick another color so it looks cleaner. What if we sell here? We know that when we sell, we cannot buy the very next day. So this is why it is still a 4. This is why I didn't say, oh, if I sell here, I'm gonna make $4 plus this other profits of $4. So I'm gonna put an 8. Now, because if you sell here, you are not gonna be able to buy the very next day at 0. So this is why it is still a 4. But at this day where I can sell at 3, well, whatever happened before, okay, at this point we don't know what are the previous day's prices. So let's say we sell here and we make $3. We know that we are going to be able to buy again at day 0 and sell it at day 4 and make our $4. But this is where we're just going to put 7 here. And then on the very first day, we know that if we buy at 1 and sell the next day, we know that along this path, we will make a maximum profit of $7. So what we're going to do is that we're just going to take our $7 minus the price that we just paid. So it's going to be $6. So I will basically put a 6 here. And this is what I'm going to return. I will return this very first case. So I know now that I made $6 and this is the maximum profit I can take, right? Because I'm gonna buy here at day one. I'm gonna sell at day two. So I'm gonna make $2. And then I'm gonna buy at this day, so day four. And I'm gonna sell at day five and I'm gonna make $4. So this is gonna be a total of $6. All right. So let's go ahead and code this. The solution is definitely not trivial, but uh, I hope you're gonna stick with me in this solution. So basically, I will create a variable and just take the land of the price because we're gonna use that quite often, and I don't want to write land prices every time. So let's just say land. So and it's gonna be the land of the prices. Now I want to create my basically in my example I had like a couple zeros, like tuple of zeros like this, so zero zeros, and I had this basically for all the day's values. Plus also I had two extra zeros at the end. So to get this, I will simply need to say for camel case in the range of n plus 1. All right, and now I want to go in the reverse order as we're doing bottom-up dynamic programming. So I will have my for loop for I in the range of, and I want to start at the last index. So I will say n minus 1, and I want to go up to the index 0. So I'm going to put my bounding index to be the minus 1 index, and I will be willing to do this in a reverse order. This is why the third value inside the brackets is a minus 1. And then there are a couple things that we can do. First, inside our buy. So the thing to consider is that we're always gonna have our buy column and we're gonna have our sell column. And for a buy column and our sell column, in both we can have a cooldown, right? Or let me just call this hold. So I will also call this by a different name for the sell and the buy. So right, so I want to see what is the maximum price I can do by buying. And remember that what we did was basically to take the next day's price. So this is going to be dp at the next column, so I plus 1. And this is going to be at the index 0. So what if we sell at the very next day? What is the money we can make? So we have to subtract to this the current prices. So prices at the index I. Okay. And for the hold, well, if we're holding, we're just gonna take the value of the next day because we're not taking any actions upon it. So we can just take the prices of the next day's buying column. So it's gonna be dp I plus 1 at the index 1. All right. And now we want to make sure that we're setting the dp at this index I in the column 1. The column 1 is the column to the right, which represented the buying column in my example. So this is going to be equal to the maximum value, as we want to maximize our profits between our buy and our hold buy. All right, that's good. Now what about selling? We know that for a selling, well, for the selling column, if we sell, we're just gonna take the prices at that current day because we're just gonna assume we're gonna take all the profits from that current day. This is the approach we had in our example. And then notice that we also want to take the we want to add to this the profit you can make by buying in 2 days, because we have to give a cooldown days if we sell at a particular day. So I will just say dp I plus 2. So we're taking the prices of that we can, well, the profit that we can make by buying in 2 days, right? Because this itself assumes that you're actually selling at this day. So if you sell at this day, you can't sell again. but you can buy in 2 days. So you're just gonna take the profit here that you can make by buying in 2 days and basically selling right now, right? So um, that can actually be out of range, right? Because we're starting at the very last index, so adding two to the last index will make this out of bound. So I just want to say if I plus 2, if this is smaller or equal than n, reason is I say smaller or equal because we're actually having an extra row of zeros. So I plus 2 can obviously be of the length n, and that will work because that will just basically refer to the additional row we added intentionally. So if this I plus 2 is in bound, this is fine, but otherwise we're just going to be willing to put a 0 here. And if we sold the price and we can and we now want to hold, what we're gonna do is that we're gonna basically take the maximum prices of selling the next day, because this is basically the case where instead of selling, we're gonna hold and sell a day later. So with that being said, the prices or the maximum profit we can make by selling a day later will be at the next row, so I plus 1, and it's going to be inside the column of selling. And also the DP at this index for the selling column is going to be equal to the maximum between either selling right now or holding. Sell. All right. And this is it, because every time basically um, we're gonna have basically to update the selling and the buying column of every single row, and every single row represents a day. So we're just gonna keep track of what is the greatest value by selling or by buying at every single day. So we're gonna do that, and the buy here is basically gonna take the maximum profits you can make by buying today. So price is I, and by selling tomorrow. So if you sell at a day here, right, that is, let's say 7, and you buy this price at 4, you're gonna make profit of 4. So buy here is gonna be 4. But now what if you hold and the next day you buy? So we're gonna basically take the next rows at the index of buying. What if at this very next day you can see that you can actually eventually along the path make $8? Well, you're just gonna set that rows at the column of buy, you're gonna set that basically to be 8, right? Because we're taking the max values. And we're gonna do the same thing for this selling option or this selling column. So we're just gonna take basically what is the greatest value between holding right now and selling tomorrow, or selling today and buying in 2 days, right? So you're gonna sell right now at your price. You're gonna take that profit. You're gonna cash out, and now we're gonna basically take the maximum price by buying in 2 days, because you have to give a cooldown to of 1 day after you sell something, and we're setting that value inside our DP to be equal to the maximum value. So then we can return the DP at the index 0, so the very first row, and we have to start by either buying or holding, because we can start by selling. This is not something that even makes sense. Like, you cannot sell without buying. So let's test this out, and this works. Awesome. So that is a dynamic programming solution. We are creating here basically an array of length n, which is the length of the prices. So if the length of the prices is n, well, we're just gonna have a space complexity of big of n. And in terms of time complexity, what is the time complexity in this algorithm? Well, we are actually going for I in the range of basically n in the reverse order, but I mean, regardless of the order in which we're going in, we're just going to go once through every single value in n. So the time complexity is also going to be big O of n, which is quite efficient. So I hope you enjoyed the video, and I hope to see you in the next one.